Good day everyone, we from Group 2 are here to present our experiment 3, which is application of first and second law of thermodynamics. My teammates are Jasmine, Gigio, Shafiq and myself Keshwini. First of all, I'll be presenting the report summary of experiment 3. Okay, the first law of thermodynamics is essentially a continuation of the law of conservation of energy, which is a fundamental principle in physics. According to the law, energy cannot be created or destroyed. It can only be transported or converted from one form to another. This law can be represented in terms of the total of the heat that flows over the borders and the work that the environment does on the system. This law also indicated that heat and work might cause a change in a system's internal energy. Because both energy and work can be quantified and measured, any change in the energy of the systems must be accompanied by a change in the energy of the environment outside the system. In short, if heat flows from the outside into the system, internal energy rises and the sign of Q and W rises. Whereas if heat flows from the system to the outside, internal energy falls and the sign of Q and W falls. A process involving the transfer of conversion of heat energy is irreversible according to the second rule of thermodynamics. That is to say, energy that is transmitted or converted is lost and cannot be restored. Okay, so for the next part of this presentation, I will carry on with the theory part of this experiment 3. The energy balance or the first law of thermodynamics is a basic calculation of heat transfer. The energy balance for the system is as shown below. E in minus E out equals to delta E of the system. The delta U of the system is equals to 0, which means the delta U of hot water plus the delta U of cold water is equals to 0. So the MC of T2 minus T1 hot water plus MC times T2 minus T1 of the cold water is equals to 0, where M is the mass, C is the heat capacity and T is temperature. So Clausius' statement states that this is not possible to heat flow from the reservoir to the cold heat reservoir without doing any work. In other words, heat can be transferred from the hot reservoir to the cold reservoir easily without doing work. So that is for theory, and I will let the next person to continue. Thank you.
Hello, my name is Gigio Sinwa and now I'll be talking about the apparatus used. So in this experiment, there are only 3 apparatus that will be used, which is the hot plate, the balance and thermometer. So now we will move on to the procedure of the experiment for today. So firstly, 2 different sizes of empty containers are weighed, and the larger container is filled with a little amount of cold water and the mass of cold water is also weighed. Then the small container is filled with hot water, which is around 80 to 90 degrees Celsius, and the mass of the hot water is weighed. The hot water container inside the cold water container is placed as depicted in the figure. So the reading of both water temperature is recorded for every 1 minute until they reach the same temperature, which is when they achieve thermal equilibrium. So now I will pass on to the next presenter. Thank you.
Good day, I am Jasmine and I'm going to present the raw data and analysis, also the result and the calculation of this experiment. So firstly, in this raw data and analysis, we are given the data heat of capacity of water, which is 4.187 kilojoule over kilogram per Kelvin. And next one is the mass of hot water, which is 0.198 kilogram, mass of cold water, which is 0.8352 kilogram, and lastly the temperature of hot water and cold water for every 1 minute interval. So here the time is the temperatures given are from the time 0 to 26 minutes. Okay, next I'm going to present the table. So this is a table that we have made in the Excel, and I'm going to do a little bit of overview. So this part is the temperature changes of hot water for every 1 minute interval, and this part is the temperature, the change of temperature of cold water for every 1 minute interval. So this is the graph that we have plotted in the Excel. This is the temperature graph of temperature for both hot and cold water against time taken. So you can see the red line is the temperature of the change in temperature of hot water, and the blue line is the change in temperature of cold water. Lastly, for my part, I'm going to talk about the calculation of this experiment. So these are the equation to find the change in temperature, which is the final temperature minus initial temperature. As for change in energy, equals to mass times heat capacity of water times the change in temperature. So this is the way to calculate the energy change for hot water. So in this part, we have calculated the change in temperature using this equation, and we get negative 42.0 Kelvin, for hot water, and for the change in energy for hot water, we use the mass of hot water given initially, which is 0.198 kilogram, times the heat capacity of water 4.187 kilojoule over kilogram over Kelvin, times the change in temperature that we have calculated just now, negative 42.0 Kelvin, and we get negative 34.819 kilojoule. Since it is negative in negative sign, meaning that this is the energy going out of the system. And so this is the next one is the energy change for cold water. The temperature change for cold water is 36 minus 28 Celsius, and we get 8 Kelvin. We have converted the 36 Celsius and the 28 Celsius both to Kelvin initially, and we get 8 Kelvin. So for the change in energy for cold water, we use the mass of cold water, which is 0.8352 kilogram, times the heat capacity of water 4.187 kilojoule over kilogram per Kelvin, times the change in temperature of cold water 8 Kelvin, and we get positive 27.9758 kilojoule. So the total energy changes, we just need to accumulate both of the energy change for hot and cold water. So E hot water and plus the energy change for hot water plus energy change for cold water, and we get negative 6.84323 kilojoule. That's all for my part. I will pass on the next person to present.
During the experiment, we can observe that temperature of hot water decreased while the temperature of cold water slightly increased as the time increased. Basically, heat is the transfer of energy from the high temperature object to the low temperature object. Being a solid, the container consists of little wiggles. The wiggles at the outer perimeter of the container can bang upon particles in cold water. So the collision between the particle of the container and the particle of the cold water results in the transfer of energy to the cold water. This slowly warms the cold water up. The average kinetic of the hot water particle gradually decreased, while the average kinetic energy of the cold water particles gradually increased, and eventually Thermal equilibrium would be reached at the point that the particles at the hot and cold water have the same average kinetic energy, and this is the second law of thermodynamics. In conclusion, there exists a useful thermodynamic variable called entropy, where it is a natural process that starts in one equilibrium state and ends in another will go in the direction that causes the entropy of the system plus the environment to increase. In this case, the heat flows naturally from an object at a higher temperature than an object at a lower temperature, and heat does not flow in the opposite direction of its accord. As a result, the final temperature of hot water is decreased while the final temperature of cold water increases. Therefore, the objective of this experiment was successfully achieved.